Hi, everybody. What we're going to do in this activity here is first you're going to scroll in your Cycle 3 notes all the way down to where it says D, Bonus Practice, AP Model Hack. This is not AP Chemistry, but a lot of the things you're doing are at that level. And one thing you see on the AP test is the College Board will often mess with you, and they will force you to draw a Lewis structure that's not to the correct molecular geometry. But then they'll ask you what the molecular geometry is to see if you really get that difference between the way we draw things on paper and the way things exist when they bond to receptors and in real life. Okay, so what they'll do here is they'll give you a skeleton structure like this, and what we're going to do is we're going to go through all of these. Okay, and the first thing I'm going to have you do is fill this in with the bonds. Okay, and then what you're going to do is you're going to draw a model of the molecular geometry, and then you're going to indicate the discrepancies in shape between the model that you drew and the actual Lewis structure that they show you there. And you're going to do this 1, 2, 3, 4, 5 times. If there's 2 boxes, don't worry about this other one, just do that. And don't worry about any of the questions here. All you're going to do is fill in the structure if it's not already done for you and indicate any discrepancy. You'll notice this one here, they've done it for you already. So the model drawing and the shape discrepancy part is all you have to do. So let me go through and do the first one with you. Okay, so what you want to do here is the first thing we're going to do is we're going to fill in the Lewis structure. Okay, this is not a problem. You guys can do this. There's a couple different ways of going about it. One way is to add everything up and do want minus have divided by 2. In this case, you'd get 8 bonds. Or you can just go through and look at normal bonding patterns. For example, we know that hydrogen always wants 1, and that means there's got to be only 1 coming off that carbon. We know that oxygen likes to have 2 bonds. And if you forget why that is, it's because, remember, oxygen has those 6 valence electrons. So it's got 2 spots there to bond. And we need 2 left over here for that one, okay, with these lone pairs filling in the gaps. So this is the correct Lewis structure. That's the first thing you're going to do, but it's not the correct shape at all, okay? So that's what you're going to do here for model drawing. And here's how you're going to do it. And listen really closely to this. You're going to inspect this problem, and you're going to look first to see if they gave you the name of the molecule. In this case, they gave you the name, methyl methanoate. Okay. In the other ones, they do not give you the name. They just give you the formula, C2H4, C2H5OH. Okay. And I believe that is the case for this one right here. Oh, they gave you the name, hydrazine. And sometimes, methylamide, give you the name. Okay, so if they don't give you the name, you're going to use the formula. This would be CH3, CH2OH. If they give you the name, you're going to use the name. So here's what I mean by that. Okay, you're like, Ramsey, shut up. Okay, so we need the drawing model. So we're going to open up Google here, and we are going to do the same search for each one. You're going to say 3D molecular model 4. And if there's the name, you're going to do the name. If there's not the name, you're going to do the formula. Like for this one here, you would put C2H4. But for the example I'm going to use, they gave me the name in the problem. So it's methyl methanoate. So I go 3D model 4, methyl methanoate. Boom. Okay, and then I go images. And what I'm looking for is I'm looking for a what's called a space-filling 3D model, something with balls. Okay, and if you notice, that red structure is what's being used for the oxygen. And here we have it. Okay, so if you look at this, I'm going to get in here close. Hydrogen is always in white, carbon is in black, oxygen is in red. And if we look here at this, you can see that double bond there is that double bond there. And I really regret that we don't have these molecules to work with, but I'm going to go ahead and draw it. Now, I'm going to draw it to the correct color. If you have different colors at home, I really encourage you to as well. I have a kit for everybody back at school. I'm sorry about that, guys. So now I'm going to do, there's my white, okay, and then I got my oxygen right here, okay, and then I got this other bond. I'm just going to use all the covalent bonds in black, going to this carbon right here, okay, and then I'm going out to, and then this is going this way, this is going that way. Okay, and you can tell that these are in 3D. This is actually coming out of the board. Sometimes they'll draw like a wedge like that. So that's my model drawing, and what's my shape discrepancy? Well, what I can do is I can label these. Okay, that's 1, and that's 1, and that's 2, and that's 2, and that right there is 3, and that's 3. I don't need to label any of the exterior hydrogens. There's no shape there. They're not central. So I can say, okay, 1 is really, what's the shape here? That's really T-planar. 2 is really bent. And 3 is really tetrahedral. So you see in this molecule, it's a larger molecule. And anytime you have a central atom here, you have shape. Here's that T-planar shape. There's no lone pairs. There's that bent shape. You can see it here. And there's the tetrahedral shape. So while this looks like a T, it's really T-planar. While that looks like linear, it's really bent. And while that looks like a cross, it's really that tetrahedral. So for the next one, you're going to say 3D molecular model 4, C2H4, after you draw these in. They kind of did it for you a little bit there, okay? And you're going to say 3D model 4, C2H5OH. And in this case, you're going to have 2 drawings, and you're going to have 2 shape discrepancies. So hopefully that makes sense. Please jump right into the Q&A if it doesn't. And hopefully that makes sense. Love you guys. Take care.